Hook. In 1903, the world's smartest scientists published papers proving that powered human flight was physically impossible. Mathematically impossible. Done deal, case closed. Orville and Wilbur Wright took off 8 weeks later. And that's just the beginning. Because engineers have been doing the impossible on a Tuesday afternoon for over a century. Promise. In the next 10 minutes, you're going to see 5 engineering projects that literal experts said could never exist. Not hard to build. Not really expensive. Impossible. Dead wrong impossible. We're talking tunnels under oceans, structures that defy gravity, machines that shouldn't exist by the laws of physics. Stick around because number 3 is going to genuinely break your brain. Section 1. Let's start with the Channel Tunnel. In 1802, French engineer Albert Mathieu proposed a tunnel under the English Channel. British scientists laughed him out of the room. For the next 180 years, every serious engineering analysis said the same thing. The seabed geology is too unpredictable. The water pressure would crush any boring machine. The tunnel would flood. Game over. Then in 1988, they started digging anyway. 11 massive tunnel boring machines chewed through 38 kilometers of chalk marl. Each machine was 9 meters wide. That's as wide as a 3-story building on its side. They dug from both ends simultaneously. British teams and French teams. They had to meet perfectly in the middle under 75 meters of ocean. The margin of error allowed? Just 2 centimeters. They actually met within 3 centimeters. Under the ocean. In the dark. In 1994, the first train rolled through at 300 kilometers per hour. The total cost was £4.65 billion. It went 80% over budget. It took longer than planned. But here's the thing. The scientists were wrong about the fundamental part. The part where they said it literally cannot be built. That part? Completely wrong. And it gets way more extreme from here. Section 2. The Burj Khalifa. 828 meters tall. 163 floors. It touches the clouds literally. The temperature at the top is noticeably cooler than at the bottom. When engineers proposed a building over 600 meters in the early 2000s, structural experts had a list of reasons it was impossible. Wind forces at that height were unsurvivable for any rigid structure. The building would sway so violently that humans inside would get motion sick constantly. The foundation couldn't support the weight. The elevator shafts would be too long for cables to function. Engineers solved every single one of those problems. They gave the building a Y-shaped cross-section. That shape confuses the wind. Seriously. Wind vortexes form on one side, then the other, but the Y-shape makes sure they never sync up. No synchronization means no catastrophic swaying. The building moves at the top. It can flex up to 1.5 meters in extreme wind. That's intentional. The foundation uses 192 piles drilled 50 meters into the ground. The total concrete poured could fill 17 Olympic swimming pools. And those elevator cables? They invented new elevator technology. High-speed elevators moving at 10 meters per second with no traditional cables at all in the upper sections. But here's what nobody talks about. People who live on the 150th floor see the sunset. Then they take the elevator down. And they watch the sunset again. Because they've descended far enough to see it a second time. That's how tall this thing is. Now stay with me. Because what they built next makes the Burj Khalifa look like a Lego project. Section 3. The Large Hadron Collider. Built by CERN. Sits 175 meters underground near Geneva. This machine is 27 kilometers in circumference. It's the largest, most complex machine ever built by human beings. Period. When it was proposed in the 1980s, physicists weren't just skeptical. They were actively hostile. The engineering requirements were described as fantasy. Here's why. To find the Higgs boson, what they called the God particle, you need to smash protons together at 99.9999991% the speed of light. Getting particles to that speed requires a vacuum more perfect than outer space. It requires superconducting magnets colder than deep space. The temperature inside the LHC is 1.9 Kelvin. That's minus 271 degrees Celsius. Colder than the void between galaxies. There are 9,593 superconducting magnets. Each one weighs up to 35 tons. They have to be cooled and maintained with liquid helium. The alignment precision required is 0.5 millimeters across 27 kilometers of tunnel. Engineers built a machine that accelerates protons to 11,245 laps around the 27-kilometer ring per second. The collision energy released in those microseconds is compared to 14 protons exploding. But controlled. Detected. Measured. In 2012, they found the Higgs boson. The particle that gives all matter its mass. The particle that literally explains why anything exists. Found with a machine that experts said couldn't be built. The computing power needed to process the data? 15 petabytes per year. That's 15 million gigabytes. Every year. This is a good moment to hit pause. Because you need to know something wild. Wild fact. The golden record sent on Voyager 1 in 1977 contains greetings in 55 languages and instructions for how to build a record player. Scientists assumed no civilization that found it could possibly play it without instructions. Voyager 1 is now 23.5 billion kilometers from Earth. It's still sending data. On 23 watts of power. That's less power than your refrigerator light bulb. Scientists said the transmitter would fail by 2000. It's 2025 and it's still transmitting. Engineers keep proving the expiration dates wrong. Every single time. Section 4. Now let's talk about the human side of impossible. The Palm Islands in Dubai. Sheikh Mohammed looked at a map of Dubai's coastline in 1999. Then he said he wanted to add 520 kilometers of new coastline to it. 520 kilometers. From nothing. From ocean. Engineers from the Netherlands, the world's experts in land reclamation, were brought in. Their first internal assessment said the scale was unprecedented. The risk of the artificial land sinking, eroding, or simply washing away was massive. They dredged 94 million cubic meters of sand from the Persian Gulf floor. They used GPS-guided dredging ships to place sand with 10-centimeter accuracy underwater. They built a 12-kilometer breakwater from 41,000 individual concrete armor units. Some of those units weigh 50 tons each. The Palm Jumeirah was completed in 2006. It took 5 years. It's visible from space. It added 78 kilometers of new coastline to Dubai. It now houses 28 hotels, thousands of homes, and an Atlantis resort that cost $1.5 billion to build. But here's the human story. The engineers had to invent new compaction techniques because underwater sand behaves completely differently than land sand. It liquefies under pressure. They had to vibrate it into stability using a method nobody had ever used at this scale before. A female engineer named Dr. Rachel Mills, a marine scientist, warned that the project would devastate the local coral ecosystem. She was right. The coral did suffer. Her team then pioneered coral transplantation techniques now used worldwide to repair artificial reef damage. Impossible projects create impossible problems, which create impossible solutions. That's the cycle. Section 5. Now for the future. And this one is happening right now. Boston Dynamics has been building robots for years. Everyone saw the videos. The ones doing backflips. Running through obstacles. But that's not the impossible part. The impossible part is the Starship rocket. SpaceX Starship is the largest and most powerful rocket ever built. 121 meters tall. 33 Raptor engines on the booster alone. Producing 7,590 tons of thrust at liftoff. In 2020, aerospace engineers from legacy agencies were publicly stating that landing an orbital-class rocket booster was physically unreasonable. The aerodynamics of catching a falling rocket going 300 meters per second were described as aspirational fantasy. In November 2024, SpaceX caught the Super Heavy booster with mechanical arms. Called chopsticks. they caught a 70-meter-tall rocket falling from space with two metal arms. The booster weighed 200 tons when it landed. The precision required? The booster had to hit a 3-meter target window traveling at highway speeds vertically, while rotating to correct its descent angle. The implications are massive. Reusable rockets could reduce the cost of getting to orbit from $10,000 per kilogram down to potentially $100 per kilogram. That's a 99% cost reduction. That's the difference between space being a government program and space being an industry. Within 20 years, the same experts who said this was impossible are now saying a Mars colony is achievable. In their lifetime. The goalposts move when engineers ignore them. Conclusion. Let's recap what just happened. 1. Scientists proved flight was impossible in 1903. Two brothers ignored them and flew 8 weeks later. 2. The Large Hadron Collider required a vacuum colder than outer space and precision measured in millimeters across 27 kilometers. It found the particle that explains why matter exists. 3. SpaceX caught a 200-ton falling rocket with metal arms in 2024. An act that experts called aspirational fantasy 4 years earlier. The pattern is always the same. Experts calculate the limits of current technology and mistake it for the limits of human possibility. Engineers don't read those memos. Or they read them and get annoyed. Every single technology you use today. Airplanes. Skyscrapers. Your phone. The internet. Vaccines. All of them had a committee somewhere that said it couldn't work. If you want more videos that make you look at the world completely differently, subscribe right now. Hit the bell. Because next week we're covering the engineering project so secret that the government denied it existed for 30 years. Trust me. You don't want to miss that one.